Da.
So, I got some splaining to do. Looks like I got a lot of splaining to do. You all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might be just hyper rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyperrulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Yes, we are back. We've concluded, or at least for right now, the 2,300-mile migration, yes, words, to the great state of Utah. We're now reporting live from the Physics Monastery. And it was a heck of a week. We had folks coming by, we're sharing ideas, passion, the debate, just the amalgamation of different ideas, seeing where the overlap was. It was nerdy as all heck. I can confirm that. And it looks like we may have gained another full-time member or so. So that should be to come. Thad is finishing up the video of his talk and should have a few more coming up. Some of them were a little delayed and stuff. And other ideas have been shared that I'm not quite ready. We're not quite ready to make public yet, pending permission. But what the heck is this thing? All right. For those of you that have been following some of this work at the monastery, part of it is to decode the constants of nature. All right. So the full story is, we're not going to do the full story. That several years back, I noticed some very interesting things. It appeared that there happened to be a way to geometrically derive the fine structure constant using some little bit of geometry, basically 1 over x plus x cubed all over 2 pi. So you get a big twist right there. Set that equal to I raised to the I raised to the negative pi divided by 2. So you get a small twist there. And I got like 6 significant digits or so. And they asked the question, what if I assumed it was right? What lambda or minus y would be required to make it equal to the fine structure constant or a derivation thereof to equal it? That magnitude happened to be the Planck mass. That was a very interesting thing. I came along around the time the whole muon G2 thing was released. That had done a video before that, and yeah, now we're here. So basically, long story short, we started with 44 constants on nature, and now we have geometric derivations and predictions for 288. So I got a lot of explaining to do. So we'll take a quick look at this. Don't worry, we're not going to do all the math and stuff like that. This is just for y'all to let me know if you notice a pattern at all here. So what we'll do is we shall embiggen this. This has been embiggened. Let's zoom in. And these are categorized by their terminal actions as far as the construction of the juz, because we're going to claim that helps us figure out things that are going on. All right, come on. Why am I not zooming in? Oh, here we go. All right. Yes, live internets, my friends. Okay. So we start over here. You can find these relationships on Codat. I believe there's supposed to be a slash between the Kelvin and the KB. It's the relationship of the Kelvin to the, I believe that's actually the Hartree energy for some, no. The Boltzmann constant, I believe. It's weird, the notation, but just notice that, okay, we're organizing this by our juz. That's j theta. Just, do you notice any patterns at all? Anywhere? I mean, these are units that are listed on NISD. You can go to the CODATA, you can look them up, but it's very interesting when you start going by, and again, we have our geometrical prescription. We have our primary action here that's usually going to be a j or like a pi or 2 pi, 4 pi. We have our dimensional ingredients, our boundary conditions. We have our terminal action, because the interesting thing is right around 7 significant decimal places, things get a wee bit wonky. Oh yeah, we had changed the inversion boundary. So we'll get to that in future videos. But just as we're going through this, does anybody notice a pattern at all? Or certain patterns that may seem to pop up. It's a very interesting thing when utilizing our dimensional ingredients. The answer's from the hyperbolic, it's changed from the hyperbolic vortex equation to the hyperbolic Mobius connection. It is more of a mouthful, but it seems to be more accurate. All right, column 1, we have 8 columns, interestingly enough. And these are the jars. This is for the radius of our equation down there. Dan, what's going on? How are we doing, my friend? Oh, hexagon. Yes. Oh, I learned some interesting things about hexagons. We were watching. We spent about 3. The new thing is we're like about 3 hours or so a day. We're watching Norman Wildberger go over like the foundations and the history of mathematics. He gets so many videos. We're starting at videos from like, I don't know, 2009. But just even going back with just the elementary mathematics and kind of seeing how it was put together, it is pretty fascinating. He's a really smart dude. But we're just going to continue on. And again, if anybody notices any pattern in some of the constructions of the things, it is interesting, because for some of these, you'll just change the sign convention. It'll be like either minus to plus or plus to minus. And again, we have certain, probably about 40, maybe 50 or so of a lot of the primary mathematical functions like pi and e and stuff like that in there. You know, things like the Backhouse constant. You get the volume of the figure 8 not there. It's hyperbolic volume. Certain interesting things you notice. All right, that's the volume of the key-scheme manifold. We've got 18s, we've got 32s, we've got 8s. What could it all mean? And again, we'll do some conjecturing as we start to break all these things down, because I got a lot of work to do. And some of these are changed. And again, if somebody's interested in this, I'd be happy to do a few more breakdowns about how to actually search for these, because apparently some of the things that I found the last time I was here with Thad, apparently they survived the cut. Oh, this is a beautiful one here. It appeared the last time, as Thad was starting to go through the different constants in nature and their relationships, that certain continents, so to speak, were being formed. This was dubbed the imaginary continent. Now, I cannot specify on why we call this the imaginary continent here, but that would be up to the observer if they notice any patterns at all. And some of these look like energy relationships between different things. I think that's the deuteron, the triton, kilograms, joules, big G right there. I think that's a newer derivation as well, which is interesting. Again, does anybody notice a pattern at what we have colloquially called the imaginary continent? You're gonna have to spend some time on this to figure it out. As we zoom back up. Okay, we get some other cool stuff here. I don't even know what some of these things are, but yeah, you can start to go through the dimensional boundaries. And again, we're trying to have a story about what's going on. If we could achieve some physical interpretation, again, any thoughts, make a comment, throw down the doobly-doo or whatnot. If you know somebody working on something that seems interested, let us know. Also, one of the things that really got me going was when I started to see megahertz pop up. I'm like, megahertz? That kind of sounds like a frequency type thing. I've heard Fractal Woman and other folks say things about that. Yes. We got the universal parabolic constant, the solution to the goat problem, the little goat ratio right there. We have some more pups down there. And again, these are organized by the Jeux construction here, the solutions to the hyperbolic vortex equation. Yes. We get into some more interesting things here. We got the alpha Feigenbaum. We've got the delta Feigenbaum. The different sides. Oh, we got the Lemniscate Island over here. Look at the Lemniscate go. Go. Go, Lemniscate, go. Oh, the iterated. That's e raised to the negative e. That's a cool one. And then we're getting down into some of these other areas. Let's go back up. I think we have like 2 more continents again. Does anybody see any patterns here? I'm just curious. Just curious. The video and other links, we should have an interactive website. The goal is by the end of the year, so folks can go in there, they can play around, we'll be able to sort things. That's the goal. If anybody would like to assist in that or is interested, feel free to hit me up on the YouTubes or on the Twitters. The links are in on the channel. So what else do we have? I think that's why we have a legend. The poster got so big that we ran out of room for some of the legend. It has to be on another thing. Oh, the rabbit constant. Ooh, rabbits are pretty neat. We keep on going down again. We're seeing our Zhuz. We have the 3 and 4s here. Oh, this is Puppy Island. I wonder why that might be. The universal parabolic constant and I don't know. It looks like a Puppy Island to me. I just think that's really cool. Yeah, these are the little things. Personally, I think physicists are natural-born trolls, but it just happens to be my opinion there. And again, this is just by the terminal action here. It's interesting to see where things pop up around the different islands and everything. But hey, Upcycle, what? It's hey, you know what? 32 does seem to pop up. It's again, interpretations are changing and stuff. It's not like it's dogma. Oh, this needs to be the way. We have open to simpler explanations. All I know is this is a model that some dude on the internet like me that kind of stopped understanding math halfway through 6th grade is literally sitting down to learn the fundamentals of mathematics from what some folks say is one of the best actual mathematics professors, at least on the internet that I know of. Yes, 6 is a perfect number. I learned that from Professor Wolfram the other day. But e to the y. It's Euler's number. The Euler Macaroni, not macaroni constant. You got 18 and 32, and those seem to be grouping up. And again, this is just from the Zhuz, but it is interesting that there do seem to be some patterns popping up here and there. And I just want to do a Gummy Bears remake. It's like gummy bears bouncing here and there and everywhere. Oh, yeah, and we get the magic angle, which happens to be a dimensionless thing that pops up. That was for a magnetic moment. And then, okay, this doesn't have all the things, but it doesn't list what the names of all the constants are. That was too big, but this is the legend. So these are the calculated values for Planck time, Planck length, Planck charge, Planck mass, Planck temperature. N is the number of dimensional ingredients. 7 is the break scale symmetry. Basically, you can have a total of 7 equally sized circles, all just touching each other, kissing, if you would, within a larger circle. Here are J1, J2, J3, and J4, and those are 2-dimensional ingredients there. Jr is the hyperbolic radius constant. We changed J theta to the hyperbolic radiant constant. Okay, I guess that makes sense. Giesecke's constant, figure out hyperbolic volume. A lot of these are known constants. We can calculate them out to as many digits as we want, given enough computational power. The one interesting thing here is the CET. As you notice, there's some green digits there. The Embry-Trefethen constant is something that, for some reason, it's a random Fibonacci-like sequence. Converges to this number, but we only know it to like 5 significant digits. That's given modern computing. Apparently, we can compute more, but the computational power required to get to the next digit is so freaking enormous. Nobody's done it yet that I know of. The interesting thing is that this popped up, and Thad basically back calculated what the missing digits would this be, because there was one answer where like that was the only thing that was within range, and it hit like all the digits. So he's making the prediction that if we actually devote the computational hardware, the next digit should be a 4. That's a tested prediction. Is it right? I don't know. But I think it would be pretty cool if it was something that we actually took a look at. So basically, these are mathematical constants on the poster. These are the units we have in SI. And interesting thing is, these are derived units. There are some very interesting characterizations with what might be going on And I'm not saying that base 10 may be built into reality, but I'm not going to say it isn't. But the continent, when I was talking about that hexagon, I was talking about basically the groupings, because right now they're kind of grouped in 8 columns, and basically we're trying to see if we can decode a pattern. That's why I want to get it all set up on the website. So anyone that wants to check it out can go check it out, investigate it for themselves, and just try to see what might be going on. There are interesting things. Plus, that one, because even apparently, like some of the videos that I watch on some of the other things, you could call that a correction term, or more along the lines of right around 7 significant digits. That's what that little the square with a cross in it. That's basically the Planck length times the Planck mass all over the Planck charge squared, which coincidentally comes out to be 10 to the negative 7, or 1 ampere, which is also a very interesting thing. But Jax, welcome, my friend. Is asking, do I think it's reality that it's just built on math, or is it how we see reality? We make the math. I don't know. When folks tend to ask the question, is math invented or discovered? I just simply respond, yes. It's the most accurate thing I can say. But that is very interesting. It's yeah. And again, when people say like a coin flip, I also say a fair coin. Because to be fair, if we flip the coin, there is a chance it could fall on that side. And then what do you do? That's why I get to say a fair coin. But that's all I got for right now. I got to do a run, grab some dinner, and try to learn a little programming later. So, hey, thank you all for watching. Take care of yourselves, everyone. It's a wacky and wild world out there. You never know when that thing, your friend, your family member, your loved one did that seems so huge, you'll never be able to forget about it. Just remember, you never know when they will depart from you. Peace out, everybody. Be safe.